Welcome to my video lecture series on computational mathematics. We are discussing about optimization theory, and there are some prerequisites for learning optimization theory. One is the vector analysis. We have already been discussed in my previous video lecture, and this is part 5. It includes matrix, basically matrix algebra, matrix definition, some terms related to matrix, operations on matrices like addition, multiplication. Addition means two matrix addition or three matrix addition, etc. Multiplication means multiplication of a matrix with a scalar quantity or multiplication of two matrices. Today we will discuss on these topics. Okay, we are discussing on mathematical preliminaries for optimization theory. We have already been discussed about vector analysis and vector algebra. Now today we will discuss on matrix. What is matrix? A rectangular array of elements, say Aij, where Aij belongs to F denoted for field, is said to be matrix of order m plus n, where m number rows, n number of columns. Now how do you denote? A matrix is denoted by something like this: A1 1, A1 2, A1 n, A2 1, A2 2, A2 n, AM1, AM2, AMn. This is matrix of order mn, which means mn. M is the number of rows, n is the number of columns. It is also denoted by this is called matrix of order m n, which means m is the number of rows, n is the number of columns. A matrix is also denoted by A equal to Aij m cross n, or Aij m comma n, or Aij m cross n. Actually, all total there are 5 notations we are using to describe matrix: 1, 2, 3, 4, 5. Now let us see for a matrix Aij m n. If m equal to 1, then it will be a row matrix, and something like this: A1, 1A1, 2, A1, N, 1 cross N. Now if n equal to 1, then it is a column matrix. Column matrix. Now if m equal to n, then it is called square matrix. Of order m, that is m cross m. Now what is equal matrix? Let A equal to Aij, m cross n, B equal to Bij, m cross n. Then A equals to B if and only if Aij equals to Bij for all I in 1 j in 1 n. Now what is identity matrix? Or unit matrix. Let In equals to 1 0 0 0 1 0 1 equal to, say, delta I j in cross in. If delta I j equal to 1 for I equal to j, equal to 0 for I not equals to j, then it is said to be identity matrix. Then the square matrix is said to be or unit matrix. Now let us see about algebraic operations. On matrix. 1. Multi of A by a scalar. Okay, let us see. A equals aij cross in, and C is a scalar quantity. B equal to bij in events. Now bij equal to C of aij for all I 1 to m, j 1 to n. Then B equal to C of A. Now this is A matrix multiplied a C quantity, C scalar quantity, and it produce B. Now addition of matrix, obviously same order. Both the matrix have to be same order. Let A equals to aij m cross n, B equal to bij m cross n, C equals to Cij m cross n. Then if Cij equal to aij plus bij for all I 1 to m, j 1 to n, then C equals plus B. Now let a small example. 1 1 2 4 minus 3 minus 1 plus 0 5 1 2 3 minus 2. Then what it will produce? It will produce 1 3 minus 3 3 0 6 6 minus 3. Now it will be observed that A plus B equal to B plus A, that is matrix addition is commutative. And we may also say A plus B plus C equal to A plus B plus C, that is, it is also associative. Now multiplication of matrices. Here is a restriction, which is multiplication of A and B, A is a matrix and B is a matrix, is possible only when number of equal to number of rows B. That is, if A equal to Aij n cross n, B equal to Bij n cross P. Now let us see that number of column is equal to number of rows. And AB equals to C equals to Cij n cross P. It will be the order of n cross P, where Cij equals to summation of k equal to 1 to n Aika Bkj. And here AB not equal to BA, which means matrix multiplication is not commutative. However, it is associative. A B C equal to A B C. If BC AB ABC ABC are defined, if those matrices are defined, that is, number of columns equal to number of rows, restriction follows. Now let us see with an example. A equals to say 1 2 2 3, B equals to 5 4 6 2. Now what is AB? AB equals 1 into 5, 1 into 5 plus 2 into 4. Here is 1 into 6, this plus 2 into 2. Here is 2, here is 2. Now for second rows, it this, that is 2 into 5, 2 into 5 plus 3 into 6, 3 into 4. Here is 2 into 6 plus 3 into 2, which produces the result 13, 22, 10, 18. Now let us see about what about BA. BA equals to B and A, 5 plus 12. Here if we sum, it will be 28, here is 8, and here is 14. Now here we clearly seen that it is clearly seen that AB not equals to BA. Now we have seen the matrix multiplication of two square matrices. Now take an example of 1 2 3 0 1 2. This is 2 rows 3 columns, 2 cross 3, and let us take 1 1 0 2 1 3 2. This is 3 rows into 2 columns. Now it satisfied for matrix multiplication. The number of columns equal to number of rows, number of columns equal to number of rows. Now it will obviously produce a 2 cross 2 matrix. Let us see. Here is the direction we are 1 into 1 plus 2 into 2 plus 3 into 3. Here 1 into 0 plus 2 into 1 plus 3 into 2. Now this is 0 plus 2 plus 6. Here is 0 plus 1 plus 4 equals to 14, 8, 8, 5. This is 2 cross 2 matrix. Now I think matrix multiplication is clear. If A be a square matrix, then A equal to A square, A cube, and so on. It holds good if it is a square matrix. Otherwise matrix multiplication is defined or not, we do not know. Now transpose of a matrix. Transpose of a matrix is denoted by AT, also denoted by AT, and if A equal to Aij M cross N, then AT equal to V equal to B Ij N cross M, where Bij equal to Aji. If we take an example that is A equal to A1 A2 A1 B1 C1 A2 B2 C2, then AT equal to A1 B1 C1 A2 B2 C2. And it may be observed that AT, again if we do the transpose, then the original matrix will be returned back. Another property is A B multiplication, and then if we get it transposed, then equals to B transpose A transpose. Now what about symmetric matrix? A square matrix is said to be symmetric matrix if A equal to AT, and it will be skew symmetric matrix if A equal to minus of AT. Now one important features, which is rank of matrix. Let A be a non-matrix of order M cross N. The rank of A is defined to be the greatest positive integer are such that A has at least one non-zero minor of order R. One order R. And if rank is R, then every minor R plus 1 equal to 0. Similarly, R plus 2 equal to 0, and so on. Now, if I write it A11, A1, 2, A13, A1 in A21, A22, A23, and so on, AM. Now, what is minor? First minor of order 2 is A11, A12, A21, A22. This is called of order 2. This is called a minor of order 2. There are so many minors of order 2, order 3 and so on. Now this is all about mathematical preliminaries of matrix. There are some more topics on it. We are just recalling the matrix theory. Okay, so let we proceed with my next video lecture series.